Greetings everybody and welcome back to another video. Today we're going to go through the Specialist Maths 2024 Exam 1. I also just finished my uni exams today, so yay, I get to spend more time making YouTube videos because I've been kind of lacking over the past few days with these exam solution videos. Haven't even done the methods 3-4 exam 2-1 yet. There's already a bunch of videos on YouTube going through that, so maybe I'll make my own sometime this week. Depends on when I feel like it. But yeah, let's do this one today. It's also pretty late. It's 9:40. I had my exam today as well, so my brains are kind of dead. But we'll push through anyways. I've also looked through this briefly. It doesn't look too bad, but yeah, it's only one way to find out. So question 1: consider the function with this rule. This is a polynomial. Show that 3z plus 2i is a factor. Well, I kind of see 3z plus 2i everywhere already. If you factor out a z squared from the first two terms, you get a z squared, and then you're left with 3z and then plus 2i. And then the last two terms is also 3z plus 2i. And then doing another factoring, z squared plus 1, 3z plus 2i. So yeah, therefore 3z plus 2i is a factor of f. Not much more to say. Hence, otherwise, solve the equation f of z equals 0. So, well, from the factoring above, we have f of z. I can factor z squared plus 1 further as z minus I, z plus I, and then a 3z plus 2i. So, if this is equal to 0, then z equals I, z equals minus I, or z equals negative. That's going to be 2/3 of an I. Plot the solutions. So we had an I, we had a negative I, and we had a negative 2/3 of an I. Prove that if x is an odd integer, then this thing is even, using a direct proof. So let x be odd. Then, what does it mean for x to be odd? Then x equals 2k plus 1 for some integer k. Okay, so therefore, if you plug it into that expression there, 2x squared minus 3x minus 7 is equal to, that's going to be 2, and then we have a 2x plus, or 2k plus 1. This is squared minus 3, 2k plus 1, and then a minus 7. So this is equal to, we have a, well, that's going to be 4k squared, but that's going to be 8k squared after multiplying by 2. Then we have a plus 4k, which is going to become plus 8k, and then we have a plus 1, which is going to become a plus 2, minus 6k minus 3 minus 7. This is 8k squared plus 2k, and then that's going to be minus 10, and then plus 2 is minus 8. So this is 2. Because for this thing to be even, you need to be able to write it as 2 times an integer. So this is 2 times 4k squared plus k and then minus 4. And this part over here is definitely an integer. So this thing is odd. Sorry, not odd, it's even. Okay, question 3. We have this rational thing. Showed that we have some particular partial fraction expansion. Okay, so, well, let's write x minus 1 squared over x plus 1, but squared. This is equal to, we have an a, and then we have a plus b over x plus 1, and then we have a plus c over x plus 1, but this is squared. And then we can multiply everything through by x plus 1 squared, giving us x minus 1 squared equals, we have an a, an x plus 1 squared, plus b, and then an x plus 1, and then a plus c. And then, well, to solve for a, b, and c, we can expand everything out and compare coefficients. Maybe a better way is just plugging in points or plugging in numbers. So we're going to let x be equal to, let's do some smart points here. Let's do 1, so the left hand side is 0. We get 0 is equal to Well, if you plug in 1, you're going to get a times 2 squared, so that's 4a, and then plus 2b, and then plus c. Let's x equal -1, so the a's and the b's will disappear, so that gives us, it's going to be 4 equals, we're going to have, yeah, a and b are going to disappear, so 4 equals c, that's good. So this is equation 1, this is equation 2. Let's get one more, because we have three unknowns there. So let's do x equals 0 is another simple one. So that's going to give us, let's see, we have 1 is equal to a plus b and then plus c. Right? Yeah, that looks right. So this is equation 3. So if we plug sub 2 into 1 and 3, we're going to get, well, c is 4, so equation 1 is going to become 4a plus 2b is equal to -4, and, well, equation 3 is going to become a plus b is equal to -3. So a plus b equals -3. That looks good. Okay, but this equation, you can write this as, well, 2a and then plus b equals -2. This equation, you can write as b is equal to minus a minus 3. Let's call this equation 4. Let's call this equation 5. So plugging 5 into 4, we're going to get 2a plus, well, minus a minus 3 is equal to -2. So this tells us that 2 is equal to, sorry, not 2, a is equal to 1, right? A is equal to 1, that's good. So this tells us that b is equal to, well, minus a minus 3, but minus a is -1, so minus a minus 3 is -4, right? So b is equal to -4. So minus 1 minus 3. So yeah, so a equals 1, b equals -4, and c equals 4. I think that's what we wanted. Yep. Part B, the graph of f has one turning point. Find the coordinates of this turning point. So let's differentiate and solve it equal to 0. Probably differentiating the partial fraction decomposition is easier, so let's do that. Let's do f prime of x is equal to, let's so a is 1, b is -4, and c is 4. So 1 disappears, and then how do you differentiate -4 over x plus 1? That's going to become 4 over x plus 1, but squared, because we have a power of -1, so that's x plus 1 to -1, then just use power rule. And then the second part is, well, power of -2, so multiply -2 by -4 gives us -8. So this is -8 over, and then you increase the power by 1, because it's in the denominator. It's x plus 1 and then cubed, and set this equal to 0. So multiplying everything through by x plus 1 squared, we're going to get 4 minus, x plus 1 cubed probably is a better choice. So we're gonna get 4 x plus 1 minus 8 is equal to 0, which tells us that's 4x plus 1 is equal to 8, which tells us that's x plus 1 is equal to 2, which tells us that x equals -1. That's weird. I did something wrong here, because isn't x equals -1 in asymptotes? Let's see here. Yeah, I can't do maths. This is 1, obviously. So x equals 1, and then f of 1 is equal to, well, if you plug 1 in, you're going to get 0. So I get a turning point at 1, 0. That was embarrassing. So sketch this thing. Well, we have a 1, 0 here. What's the y-intercept? If you plug 0 in, it seems to be 1. So let's go for 0, 1 here. Asymptotes. We have an asymptote at -1 because we have an x plus 1 in the denominator. So let's do x equals -1 here. As x approaches infinity, these are going to cancel, giving us y equals 1, because that's the constant that remains. So y equals 1. So actually the y guy, the horizontal asymptotes could pass through the y-intercept. Your graph could pass through the asymptote, because your asymptote just tells you long-term behavior. And yeah, that's all the information, I believe. So if this approaches the asymptotes, then I'm going to get a shape that looks like this. And then this also approaches the asymptotes, so something like this here. And well, notice this thing is, everything here is squared, so our graph is always positive or greater than 0. So we're not going to get a negative branch here, we're going to get a positive branch. Maybe I should get a estimates of what the other branch should look like. So let's plug in something like -4 maybe. So what's f of -4? F of -4 is -4, is it +1 or -1? -1. -1 and squared over -4 + 1 but squared. You don't have to do this, by the way. I think I'm just trying to get a reasonable estimate as to where the graph passes through. This is 25 over 9, which is a bit less than 3. So at 4 or a bit less than 3, so maybe over here. So yeah, slightly strange because this graph, yeah, we're at this point all the way out over here. That sometimes these graphs just they approach the asymptote slowly, so you're not going to get it right tied up next to the asymptote. Yeah, something like that. I forgot to label this. Y equals 1. Okay. Question 4. Consider these vectors. Find the angle between A and B. So what is A dot B? A dot B is equal to, let's try to compute this. So we have no I components. Okay. So that's just going to be 3 times -1, and then plus 3 times -2, I believe, which is -3 minus 6, which is -9. Absolute value of A is equal to the square root of 3 squared plus 3 squared, which is square root of 18, which is 3 square root of 2, I believe, because 18 is 9 times 2. Absolute value of B, well, not absolute value, magnitude. Not even magnitude, norm. I think it's norm. Yeah, norm. I forget my terminology already. Of B is equal to the square root of, that's going to be 4 plus 1 plus 4. Not 2, plus 4. So this is the square root of, that's going to be 9, which is 3. Okay, so we know cosine of theta is equal to A dot B over norm A, norm B. So this is equal to -9 over 3 root 2 times 3. So this is equal to -1 on root 2. And therefore, theta is equal to, is, that's going to be, well, when is cosine negative? It's second and third quadrant, so this is like 3 pi over 4. Perfect. We'll go with that. Find all possible values of n such that the dot product of A and C is equal to the magnitude of the cross product of A and C. So let's calculate the dot products. So A dot C, what is that? A dot C is, we have 3 times, sorry, not 3, there's no I component, so this is actually just 6, and then plus 3, oh, that's just 9, okay. What's the cross product? So A cross C, this is just some big determinants, so let's do this. So we'll do I, we have a J, and then we have a K, and then we put A, so we have 0, 33, so 0, 33 goes here, and then we put C on the next row, so that's N21. N21. So what's an easy way to go here? Let's go along. Let us go along this row here. Okay, so if you go along that row, you're going to get something that looks like, let's fix the pen here, you're going to get, well, 0 times some determinant, so that's 0, and then the 3 in the middle there, that carries a plus sign, so we have a plus 3 times, and then we have I, K, N, and 1, and then we have a minus sign, we have 3, then we do I, J, N, and 2. So let's further compute. So this is 3, I minus N and K, and then we have minus 3, that's going to be 2I, and then minus NJ. Okay, so this is equal to, we have 3I minus 3NK minus 6I, and then plus 3NJ. And this is equal to, we have a, well, negative 3I plus 3NJ minus 3NK. So that should be it there. Okay, let me just check if I get everything right here. That looks fine. Okay. So, well, we wanted to take, well, this is just A cross C still. So now I want the norm of A cross C. So norm of A cross C now is equal to the norm of that guy, but I can factor out a 3. So this is 3 negative I plus NJ, and then minus 3K. Wait, that's not 3K, that's NK. So minus NK here. And this is 3 times the square root of 1 plus n squared plus n squared. And this is 3 times the square root of n squared plus, 2n squared. And then plus 1. And if you set this cross product here equal to the dot product, which is what we wanted, we'll get 3 square root of 2n squared plus 1 equal to 9. So this tells us that 2n squared plus 1 square root is equal to 3. So 2n squared plus 1 is equal to 9, which tells you that 2n squared is equal to 8. So n squared is equal to 4. So n is equal to plus or minus 2. Now, was n positive? I don't think so. N is an integer, so yeah, n equals plus or minus 2. Perfect. Question 5. The curve with this equation for x between 1 and k and 2 is rotated about the x-axis to form a solid revolution. Show that k satisfies this cubic thing. So what's the formula for surface of revolution? It goes something like pi times the integral. We're going from 1 to k on 2 of y squared dx. So this is pi integral 1 k on 2. Y squared is the inside of that square roots dx. And I guess we just have to evaluate now. So this is equal to pi. This is going to give us kx plus 1 on x from 1 to k on 2. And this is equal to pi. If I plug in k on 2 now, I'm going to get k times k on 2, and then plus 2 on k. And plugging in 1, we're going to get, we have a k and then plus 1. So let's simplify. This is, pi. And then we have k squared plus 2 on k, and then minus k minus 1. Okay, now if we set this to be equal to 7 pi on 2, then we have, 7 pi on 2 equals pi, and then we have a k squared plus 2 on k minus 1. So in particular, if you divide by pi and then multiply by 2, we're going to get 7 is equal to 2k squared plus 4 on k minus 2k minus 2. So let's see. Let's multiply everything through by k. Yeah, let's multiply everything by k. So we're going to get 7k this is equal to 2k cubed, the plus 4, and then minus 2k squared, and then minus 2k. That looks right. So rearranging this, if you move the 7k over, we're going to get 0 is equal to 2k cubed, and then we're going to get a minus 2k squared minus a 9k and plus 4. How close was that? K cubed minus 2k squared. Why do I have a 2 there? That's not good. Oh, I missed a 2 here. So this is k squared on 2. This is k squared on 2. And then this is no k. There's no 2 here, and there's no 2 here. Minus 2k cubed minus 9 plus 4. Perfect. Okay, so question 6. The production of a brand of weed trimmers involve 3 stages: stage 1, stage 2, and stage 3, which take W1, W2, W3 hours. Here, W1 and W2, these are independent, normally distributed, and they start immediately after each other. We have mean and standard deviation. Good. Find the mean and variance of the total time. So let's see. The total time is W1 plus W2 plus W3, which is the mean of W1 plus the mean of W2 plus the mean of W3. So the mean of W1 is 1 plus the mean of W2 is 1.5, and then plus the mean of W3 is 2. So this is equal to 4.5 hours. Let's do the variance now. So the variance of W1 plus W2 plus W3, well, that's the same thing. So the variance of W1 plus the variance of W2 plus the variance of W3. The variance of W1 is, that's going to be 0.09 plus 0.16 and then plus 0.25. So this is equal to, now I have to add, so this is 0.09 plus 0.16, I believe that's 0.25 plus another 0.25, that's 0.5. So yeah, hours squared. So these are our things here. Find the variance of the total cost to produce one weed trimmer. Well, the total cost is E of, sorry, this is variance. So we want to do variance of, well, we have a cost per hour. So the total cost should be 10 times W1. And then plus 20 times W2. And then plus, that's going to be 15 times W3. So what is this? This is 100 times the variance of W1 plus 400 times the variance of W2, and then plus, what's 15? So 225, I think, plus 225. Let's move this over. I do not have enough space. So this is plus, yeah, 225 times the variance of W3. So this is equal to 100. Variance of W1, this was times 0.09 plus 400 times 0.16 plus 225 times 0.25. So this is equal to, we have a 9 plus, what's 0.16 of 400? Well, that's 16, 0.16 is 16 over 100. That's going to be 4 times 16, I think. And then plus, that's going to be 25. Oh, I can't do maths. That's a quarter. So that's like 225 over 4. So this is 9 plus 64. What's 9 plus 64? That's 73. 73 plus 225 over 4. What's 73 times 4? 73 times 4 is, how do you do this again? It's like that, and then you do 28, so 29. So So this is 292 over 4 plus 225 over 4. So how do you add numbers? I forget how to add numbers. I think it's something like this. You do 7, then a 1, 1, and then a 5. So it looks like it's 517 over 4. Costs. So this is dollars squared. Yeah. Dollars squared, whatever the units are. Okay, part C, if a single weed trimmer is produced, find the probability that the time spent at stage 2 will be less than the time spent at stage 1. So we want to compute the probability that's, the probability is time spent at stage 2, so W2 is less than time spent at stage 1, so W1. Well, this is equal to the probability W2 minus W1 is less than 0. These are normal random variables, and sums of normal random variables are normal random variables, so hence you can standardize this thing. So this is equal to the probability that Z is less than 0 minus the expectation of W2 minus W1 over the standard deviation of W2 minus W1. So something like this here. And let's compute. So, well, this is equal to the probability that Z is less than, well, we have a negative. What's the expectation of W2 minus W1? It's E of W2 minus E of W1. Right, so what's E of W2 minus E of W1? E of W2 is 1.5. So this is a 1.5. And then minus E of W1, which is 1. So this is 0.5. So we have a negative 0.5 here divided by, so now we have to do standard deviation. So let's do variance. So the variance of W2 minus W1, well, that's the variance of W2 plus the variance of W1. So that's equal to, the variance of W2 is 0.16 and then plus 0.09, so that's 0.25. So the standard deviation is the square root of that. That's going to be 0.5. So we have 0.5 here. Okay, so this is equal to the probability that Z is less than -1. Okay. So now how do we calculate this? Well, we know on our standard normal, it looks something like this. Ooh. I want something like this here. So between -1 and 1, this probability is 0.68, right? And now we want the probability Z is less than -1. So we want this probability now. So, well, this is just going to be equal to a half of the complement, 1 minus the probability that's -1 is less than Z is less than 1. So this is equal to a half of 1 minus, this is 0.68, and this is a half, 0.34, so this is 0.17. All right, so let's keep going. So question 7, what do we have? We have this differential equation and we have an initial condition, and it looks like we just want to solve it. So this looks like separation of variables. Yeah, separation of variables. Let's do it. So we have 2y square root of x squared plus 1 times dy on dx is equal to -x. So 2y dy on dx is equal to -x on the square root of x squared plus 1. So we have, 2y dy is equal to -x over the square root of x squared plus 1, and then we have a dx. So let's integrate both sides. So the integral of 2y dy is equal to negative 1/2 integral of 2x over square root of x squared plus 1. And I did that manipulation there. So the numerator in the integral is the derivative of x squared plus 1 in the square root there. So we have a y squared. That's going to be equal to negative 1/2. If you just do u sub, you're going to get the integral of du over square root of u. Right, but now I can bring the half in here. So this is negative. We have a 2. And the integral of that is just going to be negative square root of u, but u is x squared plus 1. And then we have a plus c. Okay, so y, well, now we have to, well, evaluate at x equals 0, so y equals negative 2. So when y equals 0, we get 0. So we have, let's write this out properly. So sub x equals 0 and y equals negative 2. So we're going to get, 4 is equal to negative the square root of, well, that's going to be 1 and then plus c. So c is equal to 5. Okay, so overall y is equal to the square root of 5 and minus the square root of x squared plus 1. And yeah, that should be it there. I guess really it's plus or minus. But is it? Oh, it should be minus. I missed that. It's not just square root, it's negative. Because you should choose between plus or minus, but y is negative 2 here, so you're forced to have a negative. Okay, that's a tricky part there. Almost missed that. Consider the relation x squared y squared plus xy equals 2. Using implicit differentiation, show that dy and dx equals negative y and x. Okay, so how do I implicitly differentiate? I forget how to do this. You do 2x, so differentiate the first part of the product, keep the seconds the same, plus keep the first the same, differentiate the second, so that gives you 2y, because y is a function of x, tack on an extra dy and dx, plus, same idea, differentiate the x, leaving the y, and then plus x, differentiate the y, so that's dy on dx. And this is equal to 0. So 2xy squared plus y equals, plus dy on dx. And then we have a 2x squared y, and then plus x. I'm just factoring here. This is equal to 0. Right. And now, let's see. So let's factor out a y here. So this is going to give us, so let's bring this guy over. So we have a dy, we have a dy on dx, 2x squared y, and then plus x. But I'm also going to factor out an x, so we have an x here, and then we have a 2xy plus 1. This is equal to, I'm going to factor out a y, so this gives us negative y, and then 2xy plus 1. And because 2xy plus 1 is not equal to negative 1, 2xy plus 1 is not equal to 0. So using this fact, we can divide. So this gives us, dy on dx is equal to negative y on x. Well, really, I should write x is equal to, this is negative y here. So we get some, I should put implications here as well. So it implies dy dx is equal to negative y on x. Technically, x shouldn't be 0 as well, otherwise I can't divide, but yeah, that should be fine. Find all point on this curve where the slope of the tangent is equal to negative 1. So, well, we want dy on dx the slope equals -1. So this implies that negative y on x is equal to -1. But this implies that y is equal to x. So subbing that back into the equation, what do we get? We get, let's solve it for x. So we have x to the 4, and then we have plus x squared, and then we have a -2 equals 0. So let's see if we can factor this. We have x squared and then an x squared. We have a -2, so, well, we have to have, +2 and then -1 equals 0, right? Because you multiply this gives you -2, and then you have plus 2x minus x squared. So that's plus x squared. That should be fine. So how do you solve this? Well, this won't give you any solutions, but this part will. So this tells you that x equals plus or minus 1. But we need to find the points here. So let's plug it back into the equation. So sub into the equation again. So when x equals plus or minus 1, let's see. We're going to get, well, plus or minus 1, but squared, times y squared. And then we have plus x, so this is plus or minus 1 times y. And this is equal to 2. So we get y squared plus or minus y equals 2. So now we have to solve this. So when we have a +1, we can just factor this right away, can't we? Because this is y, and then y plus or minus 1 equals, we have that 2 there to deal with. So what's the best way to do this here? So subbing that in, this shouldn't be too bad. Maybe I overcomplicated it. So let's do x equals 1, and let's see what we get. So x equals 1. If x equals 1, we're going to get x squared plus x. Sorry, no, y squared plus y equals 2. My brain's not working. Y squared plus y minus 2 equals 0. So yeah, we can factor, which gives us y plus 2, and then y minus 1 equals 0. So y equals minus 2, or y equals 1. Okay, so when x equals -1, what do we get? When x equals -1, we also get y squared, but then minus y now. So we have y squared minus y minus 2 equals 0. So this factors as y minus 2, y plus 1 equals 0. So we get y equals 2, or y equals -1. So overall, we get the points, that's going to be 1, 1, or 1, -2. And we also get -1, -1, and -1, 2. Let me just check if this is correct on Desmos actually, because now I feel like something's off here. So we have x squared, and then y squared, and then plus xy equals 2. Seems like it's correct, because when I graph it on Desmos, I get something that looks like this, and then plus some lines through the origin. So, actually there should only be 2 points. So why are there 4 points here? Well, maybe one of these don't work here, so I should probably be careful. So I don't want 2xy to be equal to 2xy can't be equal to -1. That's probably why. So I need to remember that 2xy cannot be equal to -1. So when y equals 2 here, if you do when y equals 1, 2xy is equal to, that doesn't work either. So what's going on here? So when x equals 1, we get a quadratic in y. So what's the matter here? We get a quadratic in y, but something happens. So can y be equal to 1? Well, we also have to make sure that y equals x, I guess. So because y equals 2 here, we won't get y equals x. We can't have that, and we can't have that. I guess I forgot that was a condition. So that means we should only get these solutions here, because y equals x. So these are the only points which kind of match what I drew before on Desmos. Okay, I probably would have gotten that wrong on an exam because I'm cooked. Question 9: a car is traveling along a straight flat road. The velocity of the car and its position is measured when x equals 0. The velocity is related to x by this equation. The speed detection device is positioned to detect the speed of the car as it passes the position at x equals 0. The speed limit on the road is 40. This will be activated if it's 10% more above the speed limits. Determine with evidence whether the speed detection device will be activated. So that's easy, just plug it in. So when x equals 0, let x equals 0, what do we get? We get v squared is equal to 1600 plus 672 over pi, and then our cosine of x, which is, what was it, 0. So it's our cosine of 0. What is our cosine of 0? Should be like pi on 2. So this is 1600, and then plus 672 over pi times pi on 2, which is 1600, plus that's going to be 3, and then we have a 36, I believe. It's going to be 1936. So what's v then? V is equal to, can I divide this thing by 4? Probably. So this is equal to, let's try to do long division in my head. So that's going to be 4, and then 8, and then 4 times 4. But this is 121 times 4, so this is times 16. But this is 11 squared times 4 squared. So this is equal to 44 squared. So v is equal to 44, which is greater than or equal to 1.1 times 40. So therefore, activated. Part B, find the acceleration when x equals 12. So what's the formula for acceleration? Well, there's a equals v dv dx, right? Is that the one we want to use? Maybe. I guess that could work, yeah. So v is equal to 1600, or well, I guess we want dv on dx, right? But that's hard to find unless you do implicit diff, which I don't want to do. So I guess pretty sure the other form is if you write this as a half times 2v dv dx, and then you'll notice that the integral of 2v is v squared, right? So this is a half d on dx of v squared, which is probably nicer to work with because we know what v squared is. So this is equal to a half times the derivative of that thing. So constant is gone, and then we're left with 672 over pi times inside derivative, which is 1 on 20, and then the derivative of our cosine, which is something like a negative 1 over do 1 over the square root of 1 minus the inside squared, so x minus 20, but this is squared. So when x equals 12, at x equals 12, what do we get? We get, well, first of all, that's going to be 6 divided by pi times 1 over 20 with the negative, and then we have 1 over the square root of 1 minus x is 12, so we're going to get 12 over 20. What's 12 over 20? That is 3 over 5, but this is squared. So this is equal to negative, what's 336 divided by 2? That is 166, I believe. No, 68. Yes, divided by pi times 1 on 10. And this is the 1 over square root of 1 minus, we have 9 on 25. So this is equal to negative 168 on 10 pi times 1 over the square root. 25 minus 9 is 16. 16 on 25. So this is negative 168 over 10 pi times, this is going to be 5 over 4. So can we simplify this further? Maybe. So this is equal to negative 168 divided by 4. Looks like that's going to be 4 and then 2. 42. And then we have 2 times pi. Alright, so that's going to be negative 21 divided by pi. I believe that should be right there. Negative 21 divided by pi. I'm going to go with that. That seems plausible enough. Okay, final question. We have 2 lines, and we want to find the shortest distance. Okay, so the shortest distance is some number, 14 on root 35, and we want to find m. So now I have to remember how to do this. How do you find the distance between 2 lines? I guess we'll just do it from scratch here. There's a formula for this, but I don't have the formula memorized. So let's say here's line 1. It's defined by this point in this vector. And here's line 2. It's defined by this point in this vector. What you want to do to find the distance is you take this vector over here and you project it onto the normal vector. So that's going to be the cross product, which is going to look something like this here. Right, so this vector, so if you take this vector, it's going to, also going to be perpendicular here. So we're going to take the green vector, project it onto the red vector. So there's a few things we need to compute here. We need to compute the cross product of the direction vectors. So the direction vectors are these guys here. So let's first of all compute the normal vector. Normal vector is equal to, well, determinant I, j, k. And then we'll do, that's going to be 1, 2, 1. And then negative 1, 3, 2. Okay, let's compute. So that's going to give us, well, for the I components, we do 4 minus 3, which is, what's 4 minus 3? That's 1, so that's going to give us I. For the j component, we do 2, and then plus 1, so that's going to be 3, plus 3j. For the k components, sorry, we do minus here, right? Yes. And then for the k components, we do 3 plus 2, which is 5. So this is equal to 5k. Okay, what else do we need? I need the vector, the green vector. So the green vector, I'm going to call this, let's call it v. V is equal to, well, I need 1 point to another point. So let's take this point here, and let's do 0.1 to 0.2. So 0.1 to 0.2 is 0.2 minus 0.1. So I'm going to have I, and then there's no j component, but there's a k component. So I do plus minus 1, because that's the minus 1 here. And then I do minus m. So minus 1 minus m, and then times k. And now we better project this, do the scalar resolute onto, the normal. Right, so how do you do this? What's the scalar resolute formula? I forget what the scalar resolute formula is. I know the vector resolute formula, I don't know the scalar resolute formula. Maybe I'll cheat and look up the scalar resolute formula. Let's pretend that I'm in year 12 again and I still know what the scalar resolute formula is, because I don't use that anymore, so I forget what it is. So the scalar resolute of, we want a v onto, so scalar resolute of v onto n is, we do v and then we dot it with the normal, but unit. So maybe we should find the unit normal. So unit normal, well, let's find the length of the normal. This is equal to the square root of 1 plus 9 plus 25. That's going to be the square root of 35, which looks good because we have a square root of 35 here. Okay, so let's do v dot n now. So v dot n hat is equal to 1 on square root of 35, and then it will just do v dot n. So this is equal to, well, 1. There's no j component, and the k is going to be plus, we have a 5, and then negative 1 minus m. Okay, so this is equal to, we can simplify this if we want to. I'm not going to bother, so I'm just going to set this equal to the length that we want. So this is 14 on the square root of 35. So square root of 35 is cancelled, leaving us with 1 plus 5, negative 1 minus m is equal to 14. So 5 is equal to negative 1, 5 minus 1 minus m is equal to 13. So minus 1 minus m is equal to 13 on 5. So negative m is equal to 1, or that's 5 on 5 plus 13 on 5, which is 18 on 5. So m is equal to negative 18 on 5. That should be it there. So find the values of m. So are there supposed to be multiple values? Are there 2 m's? There's just 1 m. So now, yeah, that should be fine. I think that's right. So yeah, I'll take that as the answer. So I guess that's the solution. Let me just check. So v dot n, did I get my v correct? Because v, we should do 1 and then minus 1 minus m times k. So that's right. And then you do v dot n. So this is definitely right here. Yeah, okay. That should be fine. We set this equal to 14 on 35. Yep, that should be fine there, by the looks of things. I guess maybe my only quibble here is I did my I components wrong, didn't I? This is 4 minus, oh no, that's right. It's 4 minus 3, which is 1. So maybe it isn't negative 18 on 5, I don't know. So we'll take that as the answer. And if I'm wrong, then I'll let you know in the comments. But yeah, that's the exam. I thought that was pretty easy, actually. Yeah, there weren't many tricky questions. I don't know if there were. I don't know if there were any tricky questions. Yeah, it was pretty standard. Just a lot of computation there. So yeah, we'll take these as the answers, and I'll post some comments if I got any of them. But yeah, that's all for this video. I'll see you in the next one.